Welcome to Modulus Guys, your companion to strong foundation in conceptual learning. Let's get started. All right, boys and girls, let's talk about midpoint theorem now. What is midpoint theorem? Midpoint theorem. See, midpoint theorem tells me that suppose you have a triangle like this. This is A, B, C. Now there is a line joining the midpoint of the two sides like this. You're drawing a line joining the midpoint, which means these two are equal. These two segments are equal. Got it? So in that case, you will get DE will be parallel to BC and DE will be half of BC. Got it? How can you prove it? See, to be able to establish this, guys, you have to do a small construction. Now there are two constructions that you can follow. Either you do this, extend DE to F such that DE is equals to EF. Either do this. Like we'll extend this like this, and then so this is F. These will be equal, and then I'll simply join CF. That's one way of doing it. If you don't like it, you can also draw CF parallel to AB, right? And simply extend DE so that intersection happens. It's up to you which way you want to do it. Got it? So let's do by the first construction itself. You can do either of these two constructions. Got it? So I have extended DE equals to EF, and I have no proof that CF is parallel to AB. This everything will be coming your way. Now see this. So if you consider, guys, in triangle ADE and CEF. Now notice that DE is equals to EF. This is the by construction only. This we have done on our own. Then angle E is equals to angle E. What? Okay, let me write the full angles. It's not appropriate for me to write like this. So this will be AED is CEF, which means these two angles are equal. These two angles are equal. Vertically opposite angles, right? Vertically opposite angles. And the third thing, guys, that I have is AE is equals to EC. Got it? So, guys, can I say by SAS congruence criterion, can I say triangle ADE is congruent to triangle A is C, D is F, and E is E. So I have been able to establish, guys, that this triangle and this triangle, they are congruent. That I know. I've been able to prove this. Well, in that case, angle A and angle C will be equal. Now, in that case, if this angle A and this angle C are equal, now just imagine, just see what is this. This is a line. This is another line. And this is the Z formation happening. You see the Z formation happening? So by converse of alternate interior angles, I have the license to now say that AB is definitely parallel to CF, right? Or I can certainly say from here, CF is parallel to DB. Got it? Right? At the same time, I can also say because of congruency, CF is equals to AD, but AD is equals to DB. So I understand that CF is equals to BD. So here I have proven it to you that this CF and this DB, they are parallel and equal. I have established it to you that they are parallel and equal. So guys, that means I have the license to say that BCFD, this is a parallelogram. In that case, DF is also parallel to BC and DF is also equal to BC. Got it? If DF is parallel to BC, guys, a part of it, which is DE, will also be parallel to BC, and DF, which is double of DE by construction. So this will also be true. So BC. So DE will also be half of BC. And this is exactly what we wanted, guys. This is exactly what we want. Got it? Any problems whatsoever? So this is what we have as the midpoint theorem. So guys, let's see converse of midpoint theorem now. We have converse of midpoint theorem as well. Converse of midpoint theorem. Now, what's this? Now, in this, you will be given this thing that you have a triangle, guys. Now, from one side, from the midpoint of a side, I'm drawing a line, right, which is parallel to BC. I'm drawing a line which is parallel to BC. Got it? You have to prove that this will also be the midpoint, right? So what is given now? What is given? Given is D is the midpoint. Given D is the midpoint of AB. Got it? It is also given DE is parallel to BC. Now what we have to establish? We have to establish E is also the midpoint. E is also the midpoint. Got it? Simple. Now, if E is not the midpoint, proof. We'll consider F is the midpoint. Let F be the midpoint of AC. Right? Well, in that case, if F is the midpoint, take it here. Join D with F. Right? So, in that case, I can say, what can I say? If F is the midpoint, then very clearly I can say DF will be parallel to BC. This is directly by midpoint theorem. Because if F is the midpoint, guys, D is already the midpoint, so DF will be parallel to BC, right? But the problem is, it is given to you, DE is also parallel to the same base. This is given. For a given base, from a given point, only one parallel is possible. With respect to a given base BC, like this is the line. From this point, there is only one parallel line possible, right? So if you want this to happen, both should happen. That means F and E must be coinciding, right? So that means E has to be the midpoint. We don't have a choice. Got it, guys? So this is what we have as the converse of midpoint theorem. Got it, guys? All right, guys. We have understood what is midpoint theorem. Now we shall be working on the illustrations regarding the same. So let's see what questions we have in mind. See this. So ABC is a triangle. That's good. ABC is a triangle. Okay, so done. AD is a median. AD is a median means label it, please label it as I'm labeling it. E is the midpoint. Very good. E is the midpoint. So that's good. E is the midpoint. BE is joined and produced to intersect AC. Okay. So this is F. Usually, guys, when I'm doing geometry as a part of standard thing, I try and maintain a standard coloring scheme. That is, whenever I'm drawing the diagram, I typically would use blue pen or black pen for the given data. And if there is any construction that is there, I'll use like red pen or maybe reddish color, right? So that it is very clear throughout, right? So now what? Now what? Now what we need to do? We need to prove AF is 1/3 of AC. So guys, D is the midpoint that is given to me right now. There is a bit of construction in this. So construction. Draw DG parallel to BF. So this is my construction, guys. This is DG drawn parallel to BF. Got it, guys? So guys, if you look into the triangle BFC, I'll highlight it for you. BFC, right? If you look into this triangle. Now in this triangle, D is the midpoint given. D is given, midpoint. D is midpoint given. And DG is parallel to BF, right? So therefore, by converse of midpoint theorem, G is the midpoint. G is the midpoint. There is no problem into this. Right, guys? So we can comfortably say that G is midpoint, right? Now let us go further. Now in triangle ADG, again, E is the midpoint given. E is the midpoint. And by construction, EF is parallel to DG. So therefore, we have very clearly to say that F is the midpoint. F is the midpoint of AG. So what do we have? Since G was the midpoint, FG was GC. Since F is the midpoint, AF is FG. So that means AF is FG is GC. So this explains in itself that Y is AF, 1/3 of AC. Got it, guys? I hope this is very, very clear, right? Let's see the next one. Next, E and F are respectively the midpoints of non-parallel sides of a trapezium ABCD. Then prove that EF is parallel to AB. Okay, no problem. So this is the trapezium. So guys, this is the trapezium ABCD. This is E and F are the midpoints. That's great. So this is parallel. And this is the midpoint. Right? This is the data. So whatever is given, I have drawn it. So we have to prove EF is parallel to AB and EF is half of AB plus CD. Simple. And this can be remembered as a standard result also, guys. Okay. So what we need to do? A bit of construction. So construction, what construction? Extend CD. Right? Extend CD. And extend BE to meet or intersect each other at maybe, let's say, G. So what I'm saying, extending this and I'm joining this also. So guys, this is what I have, right? So this is G. This is simple. There'll be, so from here, now if you look into the triangle, this will automatically kill the question. Now see this. So in triangle BGC, guys, now E and F are the midpoints, right? It's very clear. These two are the midpoints. This is given. So very clearly, EF is parallel to CG. Remember, CD was just a plain extension. I just extended it, right? So therefore, EF is parallel to CD. But CD is parallel to AB. So therefore, EF is parallel to AB. So that proves the first thing. I hope this much is very, very clear. Any problem? Now, what we can do further? Further, we need to establish this. This is not that difficult. Let me have one more small construction, that is join BD. Join BD. So this is let's say maybe S. Right? Now this will be very simple. So I have been able to establish EF is parallel. Now, so what I'm saying, I'm joining BD to intersect EF at S. So now what to do? Now nothing, in triangle DAB. Right? E is the midpoint. E is already the midpoint. Right? And ES is parallel to AB. So by converse of midpoint theorem, S is the midpoint. S is the midpoint. I hope there is no problem. In fact, S is the midpoint. Yes, S is the midpoint, right? So we can say ES will be half of AB. Right? It was already parallel. S is the midpoint, so ES will be half of AB. Similarly, SF will be half of CD. Got it? Add them. You'll get the answer. Add them. ES plus SF is EF. EF is half of AB plus CD. Remember, parallelism is already given. Are you getting my point? Parallelism is given, one midpoint is given. So other also has to be midpoint by converse of midpoint theorem. So you have both as the midpoints. And if both are midpoints, then ES will be parallel to ES will be half of AB. And similarly, SF will be half of CD. Easy, guys? All right. This is a very useful result. Must remember. Okay. Let's see the next thing. Next is ABC given. So this is a triangle given, guys. ABC. So this is ABC. So given is this. Now we are drawing lines which are parallel to BC. And so this is the setup. So this is Q, this is R, and this is P. So what is given? This is parallel to BC. Now this is parallel to PR, and finally this is parallel to PQ. That's what we have, right? Now, if you notice very carefully, ARCB is a parallelogram, right? It is self-explanatory. Now, that means BC is equals to AR. Similarly, BCAQ is also a parallelogram. That means BC is equals to AQ. Now, that means AQ is AR, which means A is the midpoint. Right, guys? A is the midpoint. If A is the midpoint, in a very similar mannerism, I can say, guys, A is the midpoint of QR. Similarly, B is the midpoint of PQ. And similarly, C is the midpoint of PR. Got it? So now I know that B and C are the midpoints. So in triangle, done. In triangle PQR, right? B and C are the midpoints. So by direct midpoint theorem, BC is half of QR. Got it, guys? I hope this is pretty simple. Easy. Let's see the next one. Next is show that the quadrilateral formed by joining the midpoints of the consecutive sides of a square is also a square. Right? Now, this is a very nice question, right? So if you have a quadrilateral, guys, I've already told you in the theory, right? Right? If you have a square outside, you are joining the midpoints, you will get a square. If outside is a rectangle, inside will be a rhombus. If outside is a rectangle, inside will be a rhombus. If outside is a rhombus, inside will be a rectangle, right? And if outside is a square, inside will be a square. Got it? So, how to establish? So this is a simple nut to crack. So this is the square, guys. And this is ABCD. Very standard question is this. And you are expected to remember this, okay? So this is what we have. So these are the midpoints, right? Outside. So we have to establish PQRS is a square. How can you establish? All sides are equal and diagonals are equal. One angle of that would be 90 degrees. That much if you do it, you're done. So guys, now what to do? Outside is a square. So 90, 90 and midpoints. So all sides are equal. This goes without saying. So guys, this is the data which is given. PQRS is the midpoint. Outside is a square. So all sides are equal. And hence the indication as shown. Guys, right? So now we need to prove what we wanted to prove. Right, guys? Now see. So for the comfort, let's see. So construction, small construction is there. That is join AC. So this is my construction. Now see, PQ is P and Q are midpoints. So PQ will be parallel to AC because P and Q are the midpoints. So I'm talking about triangle ABC. PQ are the midpoints. So it will be parallel to AC and PQ will be half of AC. Likewise, RS will also be parallel to AC and RS will also be half of AC. So from here, one thing is very clear, right? From here, one thing is very clear. PQ is parallel to RS and PQ is equal to RS. Any objection? So when one pair of opposite sides is parallel and equal, we can claim that PQRS is a parallelogram. So guys, I hope so far so good. There is absolutely no problem. I hope this much is very, very clear. So we have established it's a parallelogram, right? Now what? Now what we can do? right? Now next is the thing. So guys, next what we can do. Now, if you consider triangle in triangle APS and triangle BPQ, if you consider this triangle and this triangle, see AS is equals to BQ, AP is BP, and angle A is B. This is all given to you. Got it? So from here, it is easy to conclude that triangle APS, which congruency is this? SAS, right? Triangle APS is congruent to triangle BPQ, right? So from here, PQ is equal to what? PS. Are you getting my point? PQ is equals to PS. Now, if that happens, that means already I had proven it's a parallelogram. In that, I have now also proven one pair of adjacent sides are also equal. So that means I have been able to establish PQ is PS. PQ was initially equals to RS and PS was initially equals to RQ. So all sides also done. Now, if I can establish angle P is 90-degree, my job is done. Or otherwise, I can establish PR is equals to QS. One of the two, if I can establish, my job is done. So I'll be establishing this angle P is 90-degree. That is what we have to be able to establish. If I can establish it's 90-degree, my job is done. Well, in this particular setup, it is easy because if you notice, this is X, right? Got it? And they're equal. So that means X is 45-degree. Right, guys? Any problem? So this is 45-degree. Similarly, guys, this will also be 45-degree, 45-degree. Because angles opposite to equal sides are equal. Now, APB is a straight line. APB is a straight line. So it is very evident that angle P has to be 90-degree. It is very evident angle P is 90-degree. Done, guys. So I have a parallelogram PQRS in which all sides are equal. One angle is 90. That means it has to be a square. We don't have a choice. Got it? So that's how we can establish that the quadrilateral formed by joining the midpoints of a square is also a square. Easy. Let's see the next thing. Please make a note on this, right? You can pause the video. I'm moving on. So now next thing. Similarly, this was the major question, right? Rectangle rhombus is not that difficult. PQRS is a rhombus. Okay, very good. So this is a rhombus. So this time, this is a rhombus. A, B, C, D. And now what we have been given? PQRS. This is midpoint. So whatever is given, we must label. Because it's a rhombus given, so all sides are equal. And hence, halves will also be equal. So that's a big blessing, right? So prove that. No, originally is PQRS. I think labeling is to be corrected. I can draw it again, no worries. It is given PQRS is a rhombus. So PQRS is a rhombus. A, B, C, D are the midpoints. So this is the midpoint. Got it? Now because it's a rhombus, so all sides would be equal and halves are also equal. So once again, guys, in this also, I'll go with a small construction that is join PR. So this is my joining PR. Now, very similar to the previous question, guys, A and B are midpoints. So AB will be parallel to PR and AB will be half of PR, exactly from the midpoint theorem. Similarly, CD will be parallel to PR and CD will be equals to half of PR. That is self-explanatory, right? So from here, it is very evident, guys, that A, B, C, D is a parallelogram. This is exactly a repeat of the previous question, right? Parallelogram is not a problem. Now, if you want to prove it's a rectangle, you have to establish one angle is 90. Without that, we can't do it, right? Now, in the previous question, this angle was 90 given, right? So by taking equal angles, we could do it. In this scenario also, this is X, this is X, this is X, and this is X. But the problem is one angle is not given, so we cannot conclude like that. I hope this much is clear, guys. So what we do is we make one more small construction, construction number 2, that is join QS, and let's say, so join QS, right? Diagonals are meeting at X. Diagonals meet at X. Up, see, these are diagonals of a rhombus, right? So the entire thing has to be this. This is one diagonal, guys, and green is the other diagonal. And it goes without saying that this will be 90, because diagonals of a rhombus, they intersect at 90 or they bisect at 90. That's what we have. Any problem in this whatsoever? Any problem in this whatsoever? So let me label a few more points, M and N. This is N, this is M. So guys, I'm talking about this. I'm talking about this small little thing, right? Talking about this small little quadrilateral. So if you notice, guys, AN is a part of AN is a part of AB, right? MX is a part of PR. So it is obvious that AN will be parallel to MX, right? And since ABCD is a parallelogram, in a very similar mannerism, AM will be parallel to NX, right? Easy. So therefore, I can say AMXN. This is a parallelogram. Opposite angles are equal. So if angle X is 90, angle A will also be 90, because it's a small little parallelogram. Got it, guys? So this is how we can establish that ABCD is a rectangle. We already proved that it is a parallelogram initially. And in that parallelogram, we have proven one angle is 90. So I hope, guys, this is good enough for you. All right, let's see the next one. Next is show that the line segment joining the midpoints of opposite sides of a quadrilateral bisect each other. Okay, this is, so we have a quadrilateral. So this is A, B, C, D. So line segment joining the midpoints. So this is, these are the midpoint, guys. So this is P, Q, R, S, right? So these are the midpoints. Right? So let's similarly, guys, we'll do the same construction again. What's the construction in this? Join AC, right? So we have already done this twice. So because P and Q are the midpoints, guys, what we will say? What we will say? P and Q are the midpoints. So PQ is parallel to AC and PQ is half of AC by midpoint theorem. Similarly, guys, RS will be parallel to AC and RS will be equal to half of AC, right? So PQ therefore is parallel to RS and PQ is therefore equal to RS. Now that means one pair of opposite sides is what? Parallel and equal, right? So therefore we have the license to say PQRS is a parallelogram. This is a parallelogram. I hope this is clear. And if it's a parallelogram, then line segment joining the midpoints of opposite sides, right? Line segment. Now, if you notice, what are these line segments? He's talking about these line segments, right? This PR and prove they bisect each other. Yes, because they are diagonals. Diagonals of a parallelogram, they bisect each other. That is known to us, right? Well done. Easy. All right. Should we go for the next one? All right, guys. So here is the next one. So next question is ABCD is a rhombus. Okay, no problem. This is a rhombus. AB is produced to E and F in such that AE is AB. I think so. E, let's take it here. And this is, I think this is what makes sense. All of them are equal. It's a rhombus. So this is the setup. ED, and FC. They are perpendicular. So I think This is what he's trying to say. So this is what he's trying to say. Easy, guys. So it is very evident from here. Let's label it 1, 2. This is 3 and 4. See, from the diagram, because ABCD is a rhombus, so diagram is self-explanatory, right? I've already indicated equal parts. So therefore, angle 3, you can label this as maybe 5 and this is 6. So angle 5 is angle 1 plus 2, right? And 1 and 2 are equal. Why? Because of they are equal angles opposite to equal sides. So this is double of angle 1. Similarly, angle 6 will be double of angle 4, because angle 1 is equals to angle 2 and angle 3 is equals to angle 4. Got it? So guys, now what do we have? We have angle 5 is double of 1 and we have angle 6 double of 4. Add them. Angle 5 plus angle 6 is double of 1 plus 4. Easy. But guys, what is 5 plus 6? They are adjacent angles of a rhombus, right? So this will be 180. So 180 is twice of angle 1 plus angle 4. So that means angle 1 plus 4 is 90. So in triangle EGF, right? If angle E plus angle F is 90 degree as proven just now, what is angle G expected to be? 90 degree. Hence established. Got it, guys?
So I hope you've understood the topic, boys and girls. Please don't forget to like, share, and subscribe my YouTube channel. And don't forget to press the bell icon to get my latest videos. See you guys. Bye-bye.